Let us start with a very important concept, that is pointers. These are powerful elements in the entire C language. Pointer. See, pointer is a variable that contains address of another variable. Pointer is a variable that contains address of another variable. For example, if you want to declare x, it is a normal variable declaration called x. If you want to declare a pointer variable, we are using a symbol called asterisk star or asterisk p. See, here p is a pointer variable of type integer. What it means? It is a pointer variable that holds address of one integer. Once again, pointer is a variable which contains address of another variable. Let us see how pointers or variables exist. Carefully listen. Consider there is a main function integer I is equal to 10. I is a variable of type integer that contains a value called 10. Printf %d, it is an access specifier. I, what it displays? I is equal to 10. What is the memory exists? Memory. Say this. In the case of computer, entire data can be stored in the terms of a memory. Memory consists of number of cells. Each cell in the terms of rows and columns like this, like a grid, we call it as a cell or a block. Each memory cell is identified by an address. For example, we are going to identify a particular house by using house number, that is called as a reference address. Like that, we can store the data in the terms of memory. For example, I is a variable, listen carefully, I is a variable that is located at 4080 address. The memory address is 4080 and the value of I is 10. So here we can say that address, reference, memory location, cell number. If you want to display the address of a memory variable, we are using an operator, what you call ampersand. What is that? Ampersand. This is called as address of operator. What is ampersand of I? That is 4080. What it means? That is the location of the variable called I. The value of I is equal to %d, and we are going to use one more operator, what you call asterisk operator. See, in the case of programming, if you want to print memory address, it may be vary. That's why you may use, instead of %d, %u may be used. Instead of %d, we use %u. U is nothing but unsigned. Value of I is equal to %d. What it means? That is ampersand of I. What is ampersand of I? 4080. Star. Star is nothing but it is value at address operator. Ampersand is called address of operator. Star is called value at address operator. See, we are going to print the value, what you call, that is ampersand I, that is 4080. Value at 4080 is a 10. Once again, pointer is a variable. Pointer is a variable which contains address of another variable. Whenever you declare a variable like this, integer I is equal to 10, within the memory, 2 bytes will be allocated for this variable I, and the value is 10. For example, it is located at, for example, 42,000. 42,000 is an address, or we can say that 14,000. You can say 14,200. This is 14,200 is an address. Address can be defined by using an operator, what you call address of operator. And the name of the variable is I. Value at is equal to 10. So if you want to access that location, what I'm doing, asterisk, that is value at ampersand I. Ampersand I means 14,200. What is the value at 14,200? That is 10. So the answer is, got it? Got it? So let us see one example program. You can take anything, no problem. Initially, I'm declaring I is equal to 10. I am printing \n value of I is equal to percentage %d, that is I. Printer \n address of I is equal to percentage %u. I told you unsigned. What is this? Address of I. Printer \n value of I is equal to percentage %d asterisk of ampersand I. What it means? This is value at address. See this? Unsigned integer. What is the value of I? 10. What is the address of that location? That's why I. What is the value of I? This is percentage. For example, if you write D here, you will get. But the thing is, I told you, whenever the address of the memory location is too high, we are going to use a value that is in the terms of unsigned integer. Your interest, you can go for anything. This is a normal program, but defining pointer. Once again, pointer is a variable which contains address of another variable. Next, you can have one more example. Integer I is equal to 10. So separate memory variable will be allocated. Separate memory variable will be allocated. This is I. What is this? This is I. I is equal to 10, which means that I, this is the value, that is 10, and this is the address. Value of I is equal to 10, okay. Address is equal to memory location. Value at address is equal to again 10, okay. For example, j is equal to ampersand I. J is, you have to declare another variable. J holds, J holds address of variable. So J must be a pointer type variable. Which one holds the address? Pointer. Got it? Which one holds the address? Pointer variable. J is equal to ampersand I. What is ampersand I? Address of I. That is, so memory will be allocated for J at 6010 location. What J contains? 4080. Printf address of J is equal to what? Ampersand J. What is ampersand J? 6010. Value of J is equal to, what is value of J? You can directly see this. Print J, which means that 4080. Value of J in star. What is star? What is star? Address set. What is that? Star content. What is this? 4080. K is equal to, once again, we go for one more component, one more variable. K is equal to ampersand J, that is address of J, that is this one. See this. K, what is K? What is K? 6010. What is ampersand K? 5112. What is star K? What is star? What is star? Value at address. Value at. K means 6010. Star means value. That is 4080. Star. Ampersand K. What is ampersand K? 5112. What is star? Value at 5112. That is 6010. If I write, what is I? 10. What is star? Clearly observe. Very important. Very, very important. Better to get a screenshot also. What is I? 10. What is ampersand I? Star ampersand I. What is ampersand I? 4080. What is star? Value at 4080. That is 10. What is star J? Value. What is J? 4080. What is star? Value at 4080. 10. What is ampersand J? 6010. What is star 6010? 4080. What is star 4080? 10. Star K. What is K? 6010. What is star K? That is 4080. What is star 4010? 10. What is ampersand K? 5112. What is star 5112? 6010. What? Star 6010 4080. What the content of 4080? 10. You will get all the values in the terms of 10. Very important. This kind of questions may be asked in the case of MCQs for any campus interviews or any other examinations where question paper would be very tough in such a situation. Such kind of questions may be asked. Once again, I am giving you clearly information in the terms of variables and point. Let us go through one example first. I want to find addition of two numbers. Normal addition of two numbers. Let us see how. Integer, main, integer. These pointers can be used in the case of implementation of data structures, linked list, tags, queues, trees, graphs, etc. Integer A, B, and C. Printf, enter A, B values. You have to read it. Scanf, %d, %d, ampersand A, and ampersand B. C is equal to A plus B, printf sum is equal to percentage D, that is C, return 0. It's a common practice for finding sum of two numbers. Whereas in the case of I want to perform sum of two numbers by using pointers. How? Integer main, integer A, B. These are the normal variables. For your easy understanding, I'm declaring another type. You can directly write also. Star PA, star PB. Tell me what is star? It is a pointer variable. PA is a pointer variable of type integer. PB is a pointer variable of type integer. Okay. Printf, enter any two numbers. Enter any two numbers. Scanf, percentage D, ampersand A, ampersand. Okay, listen. If we give A is equal to 10, B is equal to 20. Got it? This is located at 2000, this is located at 2002, for example. What I did, I already declared a pointer variable PA and PB. These are also variable. These are at 4000 and 4002. So we are going to perform addition of two numbers by using pointers. That's why what I'm doing, PA is equal to, what is PA? PA is a pointer variable. Address of A. What is that? Address of A. PB is equal to what? Address of B. What it contains? Address of A is 2000. Address of B is 2002. Now I'm taking one more variable. C is equal to, what is star PA? What is star PA? PA means 2000. What is star? Value at 2000. What is value at 2010? Plus star PB. Printf sum value is equal to percentage D. This is C. Program is successfully executed. Return 0. Then close. Got it? Let us execute this program once. Let us execute this program. So what I am doing here, I want to perform addition of two numbers. Integer A, B, and C. I am declaring two pointer variables because I want to perform something by using two pointer variables, star PA, star PB. Printf \n, creating a new line, enter any two numbers. You have to read it. Scanf, percentage D, ampersand A, and ampersand B. So what I'm going to do, I'm going to do star PA. That means, what is PA? PA means it is a pointer variable. PA is equal to ampersand of A. I am assigning address of A to pointer variable PA. PB is equal to ampersand. PB is equal to ampersand B. So C is equal to star PA plus star PB. What is star? That is a pointer. value at address. Printf \n. Some value is %d, that is sum. Okay, here there is a small correction. Here I'm using some variable. Here also you have to use sum instead of sum. Enter two numbers 10 and 20. Some value is equal to 3. For example, if you remove these pointer values, this asterisk, if you execute the program, what it displays? Assignment to integer from integer pointer makes integer from pointer without casting invalid type argument. So if you want to store address of one variable, what we require? We require a pointer. How to declare a pointer variable? By using asterisk. Got it? By using asterisk. Say this. Enter any two numbers, that is 100 and 300. You will get some value is 400. This is the program for finding sum of two numbers. Next. You go for one more example. I told you clearly once again. This is ampersand is called as address of operator. Star is called as value of address operator. Variable 2. This variable pointer are the pointers are the variables which holds address of other variables. Integer I is equal to 10, j is equal to ampersand I. Okay, like that we are going to use integer, pointer, those are called variables. In the same way, we can write integer I is equal to 10. What happens whenever you declare I is equal to 10? This is, and this is located some address. This is called a variable I. Float A is equal to 3.14. Say this is a variable. This is located so on to address. Character CH, this is located at 3000, right? J is equal to, J must be a pointer variable. J is equal to ampersand I. What it means? Separate memory block will be created. J is equal to ampersand I memory address is 1000. That's why J contains 1000. J is located 4000. B is equal to ampersand A. What it means? Ampersand A 2000. DH is equal to ampersand CH, that is 3000. Say this. K is equal to ampersand J. K is equal to, what is ampersand J? 4000. C is equal to ampersand B. What it means? 5000. EH is equal to ampersand DH, which means that. So we are declaring these variables or pointer type variables. Now you tell me, what is the value of J? What is the value of J, B, and DH? That is 1000. Value means 1000, 2000, 3000. Good. What is star K? You tell me what is star K? Here the variable type is star K. What is star K? Value. What is star K? Value. What is star C? That is 2000. That is, say this, star K means value at address. What is the value? 4000. What is the value at 4000? That is 1000. What is star C? Star C means 5000. What is star? Value, that is 2000. What is star EH? 6000. Value is 3000. Got it? And there is a variable, what you call, there is an operator, what you call size of operator. Size of operator is an operator which can be used to define which can be used to print the size of a variable. We know integer requires 2 bytes, character requires 1 byte, float requires 4 bytes. So the size value is equal to size value, size of I. What is size of I? 2. What is y? I is e. I is integer variable. A is a float. That's why 4 bytes. CH is a character. That is, in the same way, you can get all these variables, size of j, because all these are pointer type variables which holds memory addresses. Everything will be in the terms of this 2 and the content. What is this k? What is k value? K is nothing but 4000. What is value at 4000? 1000. What is value at 1000? That is 10. What is C? C is equal to 5000. What is star C? 5000 content is 2000. What is content of 2000? 3.14. What is EH? That is equal to 6000. What is the value of 6000? 3000. What is the value of 3000? Z. That's it. In this way, we are going to perform a pointer and pointer variables. Initially, we know that there is a concept called a number system that is not a part and parcel of your syllabus now. Simply, we require the concept in the terms of a pointer. Once again, so pointer always contains addresses. Got it? Pointer always contains addresses. Integer pointer can hold integer address, integer variable address, and character pointer can hold character variable address. And we have a string, or it may be anything that contains corresponding addresses. Pointers are very, very important in the case of C programming because they can be used to acquire information from any other places indirectly, not directly. We can capture the information indirectly. So we already seen various concepts related with control structures, unions, variables, everything. So pointers may provide you clear-cut information for getting the values like this. Let us see one more element. Right? Okay. So in the same way, you can execute any number of programs, whatever you want. You can perform functions and pointers, arrays and pointers, or structures using pointers, everything. Basically, these concepts are covered under data structures. You may have a subject called a data structures. In the case of data structures, we are going to start with arrays. Arrays, stacks, queues, linked lists, trees, graphs, and so forth. Sorting, searching methods, different types of sorting methods, and everything. Okay. So this is the information initially.